And now time for everyone's favorite modeling inequalities, or as we like to call them, word problems. But don't worry, they're not so bad. Just remember back when we were doing word problems with equations, the equations make them a lot easier to figure out a lot of times. We're going to be looking for some keywords. But first thing you're going to want to do is read the question, figure out what they're asking you, and pick a variable to use. So let's see what we're working with here. It says represent each word problem algebraically by setting up an inequality. So again, you're not using an equal sign. It's going to either be a greater than, less than, greater than or equal to, or less than or equal to. Then we're going to solve. So it says 9 less than 3 times a number is less than 21. First of all, it doesn't tell me what variable to use, so I'm going to pick one. I'm going to say let x equal the number. It's kind of obvious what it's going to stand for this one, but when you get into a real life situation, a real life problem, you're going to want to state what your variable stands for. Next, I usually found the equal sign, so now I'm going to figure out where my inequality goes. So 9 less than 3 times a number is less than 21. Kind of a tricky question the way it's written, but 9 less than something means we're going to subtract. But this whole thing is less than 21, so is less than is where your symbol's going to go. And I'm going to put my less than symbol. Looks like an L. All right. Anything that comes before it goes on the left. Anything that comes after it goes on the right. So the only thing on the right-hand side is 21. Over here, 9 less than 3 times a number. If I'm doing 9 less than something, I have to start with the something. So 3 times a number, we said x. 9 less than that, minus 9. There's your inequality. We'll solve it. So 3x is less than 30, and then divide by 3. X is less than 10. All right. 1 down, 4 more to go. All right, so 2 siblings, Edwin and Ray, are both going skiing but choose different payment plans. Okay. Edwin's plan charges $45 for rentals and $5.25 per lift up the mountain. Ray's plan was a bundle where her entire day was $108. So part A says set up an inequality that models the number of trips n. Well, that's cool. So they gave us a variable up the mountain for which Edwin will pay more than Rhea. Solve the inequality. All right, so let's figure out what the inequality looks like. Right here is important. Edwin will pay more than Rhea. So Edwin more than Rhea. Another way to say more than is greater than Rhea. All right, so let's go back up and see what Edwin paid. Remember, trips up the mountain, wherever you see that is N. So he is $45 for rentals, and so plus $5.25 per lift up the mountain. So there's where your N's going to go. So we've got his $45 for his equipment plus $5.25 times the number of trips, N. And we want to know when that's greater than Rhea, and she had a bundle, so she just paid $108 for the whole day. All right, let's solve it. All right, just like anything else, your variable is going to stay there. You want to try and get everything else away from it. So we'll subtract the $45 he paid for the rentals. So we have $5.25 times N is greater than, we'll subtract that. You can use your calculator, 63. And now I'm multiplying by 5.25, so I'm going to divide. So N is greater than 12. All right. It says, what is the greatest amount of trips that Edwin can take up the mountain and still pay less than Rhea? All right. Now be careful. Look at how it's written. All right. So basically, the number of trips for him to pay more than her would be 12. All right, so let's do some guessing here. All right, we want to know when he's going to pay less than Rhea. So it's a little bit tricky here. So let's try 12. If we did 5.25 times 12 plus his $45, that, if we put it into the calculator, 5.25 times 12 plus 45, you can put it all in at once. That's exactly $108. That would be equal to Rhea. It says, what's the greatest amount of trips he can take up the mountain and pay less than her? Well, it's going to have to be 11 trips to pay less than Rhea. All right, just watch out for the wording there. All right, now you're going to see a couple terms show up in these word problems, at most and at least. All right, so think about this. If you're not sure what to do with it, think about it in terms of money. Okay, we can all relate to money. If I say I need at most $20 to go to the mall, that means that I want $20 or less. If I say I need at most $20, okay, so I want 20 or less. So to represent that, it could equal 20 or it could be less than 20. When you put those together, that's less than or equal to. So wherever you see the word at most, you're going to use less than or equal to. All right. So this would be represented as the money that I want. The value can be less than or equal to 20. If I say I want at most $20. If I say, hey, I need at least 20 to go to the mall, that means I need 20 or more. So it could be equal or greater than, put them together, greater than or equal to. So if you see at least, we're going to use greater than or equal to. So the amount of money needs to be greater than or equal to $20. All right, so let's apply that here. It says when the product of a number and 3 is increased by 12, the result is at least 32. So this part right here. So if I say, hey, I want at least $32, that means I want 32 or more. So I'm going to be doing greater than or equal to 32. All right, so there's part of my inequality. Now let's figure out the rest. The product of a number and 3 is increased by 12. Well, pick a variable. So I'll just use n. Let n equal the number. So the product of a number and 3, that's just 3n. Increased by 12 plus 12. All right, and then you would just solve it. All right, so we'd subtract 12. 3n is greater than or equal to 20. Divide by 3. I'm going to get a decimal, that's okay. 20 divided by 3. 6.6 repeating, or you can hit math, enter, whatever you prefer. 20 over 3. All right, either of those is fine. All right, couple more. 5 less than half a number is at least 7. Again, at least 7. I want at least $7. That means I want 7 or more. All right, so it's greater than or equal to 7. 5 less than half a number. Half a number, 1/2 times the number. 5 less than that, minus 5. So again, I'm using n, so let n equal the number. 5 less than half a number, all right, is greater than or equal to 7. Add 5. 1/2 times n is greater than or equal to 12. Well, if you want to get rid of multiplying by half, you can divide by half. All right, so if I did 12 divided by 0.5, or alpha y equals 1/2, 24. Half of what is 20, or half of what is 12? 24, it makes sense. So you could divide by a half or by 0.5. Either way, n is greater than or equal to 24. All right, last example. George works at a local grocery store making $55 each week. He already has $120 saved for an iPad that costs $450. Write and solve an inequality, don't put an equal sign, to determine the minimum number of weeks he must work in order to have enough money to buy the iPad. All right, if he wants to buy an iPad, it's $450. It could be equal to $450, or he's going to need more than $450. He can't have less than $450 or he won't have enough money. So we put those together. The amount of money he needs has to be greater than or equal to $450. So he's making $55 each week. I'm going to use W. W equals the number of weeks. $55 each week plus the $120 he already has saved. Subtract $120. $55 each week has to be greater than or equal to $330. Divide by 55. And you get exactly W is greater than or equal to 6. So he will need to work for 6 weeks in order to save up enough for that iPad. All right, your homework is going to be the next couple of pages, page 9 and 10, and I will list that as an assignment. But if you have questions in the meantime, don't forget you can stop by the Math Lab or send me an email. I'm happy to help. Have a great day.